word problems. All right, so then that's the end of the stuff the next test is on. So 6 to the x power is 36. What is x? 2. How do you know the answer is 2? Because 6 squared is 36, huh? Great.
Well, and we can do it backwards like you taught us. Put the 6 to...
Yeah, you can make that 36 6 squared.
Yeah.
Yep. You can just, that's good enough for now. 2, x is 2. Very good. Done. Next question. Good so far? You can. I mean, I'm always fine with that. Can you just look at that one and tell me what the answer is? Is it 8? I don't think so. What's that? You know what you could do? Whip out that handy-dandy calculator and go 2 times 2 times 2 times 2 times 2 until you get 64. Or you could use the power button. You can just try different powers. You know, like 2 to the power of, I don't know if you have a power button that's x to the y, or maybe you have the up arrow kind. You know, whatever your power button is on your calculator, you can just hit it and then try guessing. Maybe it's 4. Hit equals. If that doesn't work, try 5. Hit equals. You know, just keep playing around, trying different powers on 2 till you get 64. What power does it take? 6. X is 6. Is that good? We're solving by trial and error. All right. Let's keep going. Three to the 7x equals 81. Okay. What do you think? This one's not nearly so obvious, is it? This one we're kind of done with our solve by observation method. We're going to need some math techniques here. Here's what you do. You make, I should let me give you the type of problem it is first off. When x is in power, that's what has happened here. X has climbed into the power zone. When x climbs up there into the power zone, that's what's kind of unique about this question. I know it's hard in math. One of the things that's hard in math is they all can start to look alike. So I'm trying to help you. Notice what's different here. Notice what stands out. X has climbed into the power zone. So when that happens, make the bases the same. Step 1, make the bases the same. Then set powers equal and solve. So make the bases the same. What am I talking about? Well, that 81, take your calculator and take 3 to some power. Try different powers out. Or just multiply 3's and keep count. 3 times 3 times 3, you know, till you get it. And the answer is 3 to what power is 81? 4th, right? You able to get that? You know that, because 9 times 9 is 81, and that's 3 squared, huh? You know 4 3's makes 81, right? All right, so what? Well, make the bases the same. That I've done. Step 2, set the powers equal, meaning grab just these powers and say, hey, powers, you've got to be equal. And ignore the bases completely. Bye-bye 3's. Why? Because that's true, huh? If 3 to some power equals 3 to some other power, those powers have to be equal. Or 3 to one of them wouldn't equal 3 to the other if they were different powers, right? Let me say that a few times. You want to feel the truth of that. Right? If 3 to something is equaling 3 to something else, those powers would have to be equal. Or 3 to, if they were different, 3 to one of them wouldn't equal 3 to the other. Right? If I said, hey, I took 3 to some power, and I took 3 to some other power, and they came out equal. Well, then those powers must have been the same. Or 3 to one of them wouldn't come out equal to 3 to the other if those were different powers. Right? Like 3 to the second's not going to equal 3 to the 4th, for example. No way. Right? The only way that this is equal to that, as it tells us they are, is if those powers are equal. It's got to be the case. And so I can say powers, you must be equal. Logically, that's got to be the case. 7x has got to equal 4. And then how do we finish solving for x there?
Divide by 7.
Divide by the 7. Boom, there it is, 4 sevenths. Would have been hard to guess at that one. Is that good? X is 4 sevenths. Hey, is that really true?
Mm-hmm.
Let's go back where the x was. Just, you don't have to check it or anything. It's guaranteed, but just see it. It's nice to see it every now and then. We put in 4 sevenths there. The 7's in cancel. 3 to the 4th, 81, yep. 4 sevenths is the truth. How does math always do? How did it know 4 sevenths? Because we're using logic.
28 sevenths is 4.
So 3 to the 4x is 27. So do the same thing. So what's step 1?
Make the bases the same.
Make the bases the same, yeah. So x in power, step 1. Make the bases, bless you. Make the bases the same. Step 2, set the powers equal. So 27 is 3 to the 3rd. Did you find that? Use your calculator, or you probably just know it. 3 times 3 times 3 is 27. So I've made, there's step 1. I made the bases the same. So now, step 2, set the powers equal. Yeah. Because if 3 to something is equaling 3 to something else, those powers have got to be the same, or 3 to one of them wouldn't equal 3 to the other if they were different.
What happens if you can't make the bases the same?
Yeah. We got to do something else. Good observation. Yeah, and we'll do it. But not for now. Divide by 4 on both sides. 3/4 is the answer. Yeah, good observation. This is a hokey method. I don't know if anybody's noticed. You can't always make the bases the same. It's a gimmick. Right. That's all we got for now.
Last semester, a chemistry teacher posed to me a question. She's like, can you solve this? And
Yeah. Like, what if this was a 26 over here?
Yeah.
You can't make that 3 to something. What are you going to do then? That's coming later. But for now, they're going to perfectly make these things where you can make the two bases the same. They're contrived questions, meaning they're purposely making them nice. Because this is really a hokey method.
And then they're going to like rip the carpet up.
How long? I thought it was later. All right. 3 to the x power is 19. 3 to the x power is 19. So we can't make the bases the same, can we? You can't make 19 3 to something. So what are you going to do? How are we going to solve that? Anybody have any ideas? We're going to do something kind of tricky. You've actually done it before.
Is it going to be a log?
Think about, well, let's try some different things. Could I divide both sides by 3? Trying to get x alone, right? Trying to get x alone. Could I divide both sides by 3?
Yeah.
Would that just cancel them and that, there it is, 19 thirds. Is that right? Is that true what I just did there? No, because that's 3 to the x power. That's not 3 times x. If that x was down on the base level, then yeah, you could just divide by 3. If it's just 3 times x, then you can just divide, right? Because dividing is the opposite of times, and that would cancel the 3, and that would give you x. But that's not what's good. X is up here in the power zone. It's 3 to the x power, not 3 times x. So I can't get rid of the 3 by just dividing, right? So that's not going to work. How do I get that x alone? I'm trying to get x alone, right? Want to get rid of the 3. Any ideas? Ideas? Do what's up? Multiply. So if I multiply both sides, but whatever I do to one side, I have to the other, huh? You got to keep the balance. Now I've got more x's.
What about log base 3 times 19? Oh, no.
Whatever I do, I got to do to both sides, right? Whenever you do something, you got to do it to both sides. Do you see the problem? Do you see why this is so difficult? If that 3 was just on the base level like that, like I said, we would just divide by 3, huh? If that 3 was just added, then I would just subtract 3. So if 3 was just times, I would divide. If it was just added, I would subtract. But it's like to the power. Yeah, well, could I, what about the root? Good idea. Good idea, Abraham. What about the root idea? Could I do some root stuff? Like, what about, if I had, you guys know if you have, that's the right thing. If you have the x to the third power is 19 or whatever, how would you solve for x there? How would you get rid of that 3 in the power? What's opposite of 3 in a power? Third root, huh? Whatever you do to one side, you have to do the other, and that would get rid of it, and that would give you x alone. But that's different, huh? Yeah, this isn't 3 in the power, it's x in the power. See how difficult it is when x itself climbs into power?
Can you just say x equal to 0?
Just make up an answer? I'm trying to find out what x is. I can't say he's 0. I don't know that he's 0. I'm trying to get him alone. I'm trying to get this 3 to go away, so x will be alone, but I got to do it legally. All right, I wanted to help you to appreciate the problem for just a minute. We have, the problem is that 3 is in the power zone. Isn't that x is in the power zone. That's the fun. Think with me on the fundamental issue. X is up there, and he's in the power zone. If I could somehow just get him to come down from, like if he could just come down to the base level like that, then I could just divide by 3 and I'd be done, right? Do I have anything that takes things from the power zone and brings them down? Yeah, that's what we just learned right there. I saw you, Abraham, looking over there. Good place to look. Property number 3. He says, here I am, to the rescue, right? If you get a log in there, then the power will just come down. Remember I said that was the greatest quality of the log? This is why. Because there's no other way to solve this kind of thing. When x climbs into the power, the way to get it out of power is you take the ln. You can do regular log or ln. I'll just do ln. Doesn't really matter. It'll work the same either way. But you got to do both sides, right? Because you got to keep the balance, right? We have 2 things are equal, treat them the same, still be equal. Or if you do one side, do the other, right? So here's what you do. You do the ln of both sides because you got to keep the balance. And now, this power, we learned property number 3. Whenever you have, it works for regular log or ln. They're both just different types of logs. Same thing. Powers come down. So it's x ln 3. The other side hasn't changed. Is that good to there? That x power comes down.
So how'd you know it was ln instead of
Regular log?
Yeah.
You could do either one. Both would work fine. So you could do regular log on both sides or ln on both sides. I'm going to suggest ln because in a bit they're going to do e's and it'll be easier for that reason at this time. For this reason at that time. Anyway, so now x is down on the base level. Problem over, right? X is out of power. So now just divide by ln 3 on both sides. Right now it's no big deal at all. Now because x is on the base level, you just divide. There it is. They want you to type it on your calculator. You guys have your calculator? Get an answer there. ln 19 divided by ln 3. I'm getting 2 point, how many places? Then round to 4 places. Okay, 2.6801. 2.6801. Can you get that okay in your calculator? So what did we see there? When x is in the power, let me write the instructions about what we've just seen. When x is in the power, number 1, try to make bases the same. So that's the first thing. You should try to make the bases the same. But we see on this one you can't. Step 2, ln both sides. So if you can't do it the way we did it on the last two problems and make the bases the same, then ln both sides. That's why we're so into the log properties, because of that ability to solve when x is in power. That's very useful for all kinds of real-life problems, which we will see on Monday. Some real-life banking, population. We'll do some sound formulas, some acid and bases, all kinds of real-life situations where you have equations with x in the power zone. And the only way to solve them is natural logs, both sides. Is that okay? Is that good? Makes sense? Can I flash off that? Got these 2 steps down. All right, let's try. Okay, so 3 to the x power is 26. So x is in the power zone. Ln of both sides. So ln both sides, and then take that x power and bring it down to the front. We good to there so far? That makes sense? Take ln of both sides, and then the power comes down. Then you can just divide. Once you got that x out of power, it's no big deal. There you go. Hit the buttons on your calculator. And I'm getting 2.9656. They went 3 places?
Oh, they went 3? Or did they say 4?
9656. I assume they say 4. I don't see it on my screen. Yeah, 4. 9656. 2.9656. We good? Not making sense on that? ln both sides. We okay? You guys look tired. Are you tired? 1 or 2 more. We'll be done. Is it warm in here?
Yes.
Oh, why it's warm? It's November. Why is it warm in here? All right. Okay, so 5 to the 5x minus 7 is 25. X is in power. So what do we try first?
Make the bases the same.
Try to make the bases the same. This time, you don't have to do the ln thing. This will be easier. This time, what can you make 25 become? 5 to the second power, right? Mm-hmm. You can make the bases the same. I would do that. So if you can, if that was a 24 or something, then there'd be no way to make it 5 to something. But if it's 25, that's just 5 to the second power. That makes the bases the same. So remember, when x is in power, first, step 1, try to make bases the same. Try to make the bases the same. So both sides, good. Now, and once the bases are the same, remember you can just set the powers equal. Is that good? Just set those powers equal. So 5x minus 7 is 2. All right, good. So once the bases are the same, just set the powers equal and then solve from there. So add 7 to both. 5x is 9, divide by 5, 9/5. So again, if that had been something like 24, what would I have done instead? ln of both sides, right? If you can't make the bases the same, if the number on the right is weird, you know, and you can't make the bases the same, then ln both sides. But if you can make the bases the same, that's easier. So make the bases the same, set the powers equal. Good, we good on there? Is that making good sense? You happy? Questions on that one?